There's a number of things you can do at home.
Straight to crackle.
Straight to crackle.
You got
Okay, so last time we talked about the Tyndall effect, and that's that crazy phenomenon when you can shine a laser or light through a solution, and you can see the beam, it's a colloid. So if the beam is entirely blocked, it's a suspension. If you can see the beam, but it passes through, it's a colloid. And if it passes through, you can't see it in the solution, it's a solution. So today, we're going to learn about molarity. Okay? And we talked about that at the beginning of the unit. One thing we need to discuss is the idea that molecules disassociate. Okay? Who can raise their hand and give me their own definition in their own words of what disassociation means? So not be related to something? Okay, let's develop that.
So when you have like a happy molecule and an unhappy molecule, they go apart and they go their separate ways.
They go their separate ways? Okay, so happy and unhappy molecules separate. What does it mean when a molecule disassociates into ions? What does that mean? Break apart. Okay, so like sodium chloride, when it disassociates into a single sodium ion and a single chlorine ion. Like when you have your cheapo skateboard, you're skating down the road, and then you hit a bump and the wheels fall off. How many wheels disassociate from the skateboard? 4, unless you have a super, like 4. I don't know what kind of skateboard has 3, but 4. Okay, so you have 4 wheels to every skateboard, and when that skateboard disassociates, it falls apart because you didn't tighten the wheels, then you have 5 pieces, right? Well, concentration works very, very similarly. So let me show you what I mean. If you have a concentration of sodium chloride that is 1 molar, what is the concentration of the sodium ion? It's not a trick question. 1 molar, right. So if your molecule is 1 molar in concentration, then your sodium ion is 1 molar in concentration because it's a 1-to-1 ratio. There's 1 sodium in the molecule. Does that make sense? Okay. By the same idea, what's the concentration of the chlorine ion? It's 1 molar. Okay, does that make sense? Here's where it gets tricky. If you have a mole of molecules, that means you get a mole of sodium and a mole of chlorine. If you have 1 molar concentration molecules, that means you have 1 molar concentration sodium and 1 molar concentration chlorine. Make sense? What is the concentration of all ions? In other words, if you had a 1 molar NaCl solution, what's the concentration of all the ions it makes? 2 molar, exactly. The concentration would be 2.0 molar because you get 1 molar for the sodium, 1 molar for the chlorine, so the entire concentration would be 2 molar. Give me a thumbs up if that's starting to make a little bit of sense. Okay, first grade had a lot of trouble with this, but we'll maybe practice. Okay, so using these relationships and what we learned about with the polyatomic, sulfate, nitrate, and carbonate, see if you can figure out how these ions disassociate. In other words, how many ions you have when you put the molecule into solution, when it disassociates. So go ahead and scribble those down, if you would, please. copper sulfate dissociates into a copper ion and a sulfate ion. With a show of fingers, how many magnesium ions are present when magnesium nitrate dissociates? How many, is it 1, 2, 3, 4? How many magnesium ions dissociate? I'm seeing 2 1s and, no, the 3 turned into a 1, okay.
I gotta go smart.
Go with this. Oh, don't sell yourself short, you're smart.
Where's Jimmy?
1, 1, okay, yeah, so how many magnesiums? 1. There's 1 magnesium in the molecule, so when it dissociates, you're going to get 1. By the same idea, how many nitrates are you going to get? Show me with your fingers how many nitrate ions you're going to get in each magnesium nitrate. I'm seeing some 2s and 2s, a 1, a 2, 2, 2, yeah, 2. Okay. So magnesium, you're going to have 1. Nitrate, you're going to have 2. So when magnesium nitrate dissociates, it's going to dissociate into 1 magnesium and 2 nitrates. Give me a thumbs up if that makes sense to you. Okay, now, using the math you learned when you were 4, what is 1 plus 2? 3. So how many overall ions are present in solution? 3. Question?
It's 2 plus again. About magnesium.
That's a magnesium 2 plus ion. Magnesium has an oxidation of 2 plus because it's in period or group 2. Group 2. Everything group 2 is plus 2. All nitrates are minus 1. So, now that you've had some practice here, when sodium carbonate dissociates, how many sodium ions do you get with your fingers? Some of you don't have any fingers. I'm sorry. If you have, okay, everybody who has fingers, 2, yeah, 2. And how many carbonates do you get? Everybody who has fingers, 1, yeah. You're going to get 2 sodiums and 1 carbonate. Now, that's how it dissociates. Now I want to show you why this is useful. Let's say I have some copper sulfate and I make a solution of copper sulfate. How concentrated is my solution of copper sulfate? Just throw a number out. 10? Okay, so the copper sulfate is 10 molar concentrated. If that's the case, then what is the concentration of the copper ions? 10. It's a 1-to-1 ratio. There's 1 copper for every copper sulfate. What's the concentration of sulfate ions? Also 10. And if that's the case, what is the concentration of all the ions? 20 molar. See how that works? We do the same thing with magnesium nitrate. Let's take our magnesium nitrate, MgSO4, and it breaks down into Mg2 plus actually M nitrate. Let's try magnesium nitrate. That would make more sense. Magnesium nitrate would break down into 2NO3 minus. They need new pens. Okay, what's the concentration of my magnesium nitrate molecule? Throw it out. 7. Okay, so 7 molar for magnesium nitrate. What's the concentration of the magnesium ion? 7 molar. And the concentration of the nitrate ion? No. 14 molar. Exactly. Because there's twice as much. So the concentration of all the ions is 21 molar. See how this works? This is why this is useful. So if you know the concentration of the molecule, you can know the concentration of the individual ions. Okay. Questions? Then off we go. Respect my molarity. Concentration. There's a whole bunch of concentration units that we can use in chemistry. We're going to focus on 1. Just 1. Molarity. Molarity. There's parts per billion, molality, normality. We're going to focus on molarity. Now, molarity, you learned at the very beginning of this unit, is the concentration of something, the numerical or the quantitative concentration of something. And it's given this formula. Amount of solute divided by moles of solution. So molarity is always going to be this formula. It's always going to be molarity equals moles over liters. It's always going to have that formula. There is something kind of goofy about molarity. Chemists love shorthand. They love shortcuts. So when you see a number or a thing in brackets, like that, it means concentration. So if you saw something that looked like this, Cl minus in brackets, that means the molarity of the Cl ion concentration. Brackets just mean molarity. And I mention that because sometimes you see that in internet tutorials or textbooks. Probably not, but I've got to check. But just know that when you see something in brackets, that means molarity. Okay. Questions before we jump right in and do practice? Okay. Now, the math is simple. Algebra? I guess it's algebra. But sometimes the volume will not be given to you in liters. Sometimes the volume will be given to you in milliliters. There are 1,000 milliliters in a liter. So if you needed to convert between milliliters and liters, what would you do? Move the decimal place 3 places, or divide by 1,000. So MT, DP, 3P, or divide by 1,000. So if you need to get from milliliters to liters, move the decimal place 3 places, or divide by 1,000. Now sometimes, it's not going to give you the volume, it's not going to give you the moles, it might give you grams. What do you do with grams? Yeah, turn grams into moles by using gram per mole. And where does gram per mole come from? Gram per mole comes from the what? Periodic table. So if grams is given to you instead of moles, you're going to have to use the periodic table to turn it into moles. And if volume is given to you in milliliters, move the decimal 3 places to get the liters. Does this idea make sense? Let's do some practice. Okay, molarity exercises. We're going to start small. What is the concentration in molarity when 3 moles of NaCl are dissolved in 2 liters of water? Now, for today's exercise, you will need a calculator capable of doing exponential notation. That's the EE and the times 10 to the whatevers. So if you don't have that, then borrow one. There's a whole bunch up here. Looks like I'm down to about a half a dozen scientifics. Oh well, they've served their purpose. I bought them off eBay about 10 years ago. If you want to get a calculator, if you're good at planning ahead, you can get a steal on eBay by buying calculators. Yeah. Cool. Yeah, you can get a really great deal on pretty much any kind of calculator in June because people are like, I'm done with school. I'm going to sell my calculator and buy an Xbox game. All right. I bought these guys crate of these things in June 10 years ago at $5 each. And scientifics are really cheap. Graphing calculators you can get for about half price on eBay.
I bought mine because I thought they had those crappy old ones. And then 2 weeks after I bought it, they got a great load of new ones. And I was like,
It only took TI about 12 years to come up with a colored screen.
yeah, well, I had Pac-Man on it, but I didn't charge it, so it died and cleared the RAM.
Oh, yeah.
And Tetris. So,
Want to hear a fun story about clearing RAM?
yeah.
I had a TI-80. It was blue. My junior year in high school. My junior year in high school, I had a TI-80, basically the exact same thing as your TI-83s. Black and white screen, programmable. And I programmed a bunch of stuff in there, not the least of which is how to solve the quadratic formula. When I was in high school, I never solved the quadratic formula on my own in class. I just programmed it at home, or maybe during some other class. I programmed it in BASIC, because it was like if, then, add this, multiply, just basic programming they have in the calculator. You know you can actually write programs in your calculators?
Yes.
Yeah.
So I programmed it, so when I hit the program, it just said A, B, C, and hit it, and it would give me the roots. And it was really great. The whole thing took me maybe 4 or 5 hours to write and debug, so I had the program all done. And I handed my calculator to a friend to do something in pre-calculus. And she handed it to someone else. And at some point, about 20 minutes later, we're doing our exercises. I was done. I kind of leaned back. I was like, "You have still my calculator?" She's like, "No, so-and-so has it." I'm like, "Hey, so-and-so, do you have my calculator?" "Yeah." He handed it to me, and what was on the screen said, "Memory cleared." I'm like,
Whole program.
what a jerk. So, yeah.
That sucks.
No, we don't have to resort to violence. She became a doctor. I don't know what happened to him. 2 ways. You go into your mode and tell it to clear memory, or hold the button down in the back. It has a little tiny little button on the back. Yeah. Okay, anyway, so doing our molarity exercises, 3 moles of NaCl are dissolved in 2 liters of water. So best thing to do, again, I always write my formula down because I like writing formulas down. Moles over liters. What's my moles here? 3.0 moles. What's my volume? 2.0 liters. And so what's the concentration? 1.5 molar. 1.5 molar NaCl. You can if you want, but putting an M after it's the same thing. What they usually do when they're asking for brackets is they'll have a really long ion. So rather than saying the concentration of acetate, they just do this. C3 H2O minus bracket. That means the concentration of acetate. So, or if they want the concentration of dimethyl mercury, blah, 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 then you're like, put the whole, this formula in there and then have to write the concentration of. Okay, so if NaCl is 1.5 molar, what's the concentration of the Na? 1.5 molar. And the concentration of Cl? 1.5 molar. And the concentration of all the ions? 3. 3 molar. Okay. Do you see how that works? Let's move on. How much in liters of a 0.1 molar solution do you need to get 2 moles of solute? Oh no, he's not asking for the moles anymore. What's it asking for? Yeah, the volume. So you're going to need to solve for a denominator. And remember, you have an equal sign, you can check your work. I don't understand why people are so resistant to check their work. Me, I'm a big worrywart. I always check my work. I'm afraid of getting things wrong. Yes.
Can I run some numbers?
Yes.
They're not lightsabers, it's copyright.
That's right. But you know what I get to say when he's old enough to understand it? I get to say, Luke, I am your father. My second kid's named Luke.
You know he never said Luke when he said that?
Yeah. Search your feelings, you know it to be true. Here's your birth certificate, my name's right on it.
Did you say Goku?
Yeah, dude. Goku.
Pretty epic.
No, because these would break. Because I would play to win. Okay, so we're searching for the denominator. So 0.1 molar equals 2.0 moles over X liters. What did you get for the volume? How much? 20 liters? Yeah. So it means if I want a 0.1 molar solution, I have 2 moles of my substance, I'm going to dissolve it in 20 liters. Okay, moving on. How many moles of NaOH are present in 300 milliliters of a 1 molar solution?
Wait, how do you do this? One half. How'd you get 40? I keep getting 405. Wait, are we dividing 0.10 divided by 2? That's it looks like we multiply it.
I mostly just that even though outliers that I'm gonna teach.
Okay, it sounds like from the chatter that you got an answer.
Yeah.
0.3? All right, so 0.3 moles of NaOH are present when you have 300 milliliters of a 1 molar solution. Right.
Well, I had a question about the other one, the leading one. I got 0.2. I was wondering how you got 20.
You probably divided when you should. Oh, you probably multiplied when you should have divided. Yeah. So if you're trying to find x here, I don't want to step on your math teacher's toes, but I always just swap these. It's like cross multiplying. So if you want to find x, one way is to multiply both sides by x, divide both sides by 1, or do what I do and just put this over 1 and cross multiply.
Okay.
Does that make sense?
Yeah.
So use whatever algebraic technique you want, but when I'm trying to find a denominator, I just put the other thing over 1 and cross multiply. Okay, so if there are 0.3 moles of NaOH, how many moles of Na are present? 0.3 mole. And how many moles of hydroxide? 0.3 moles. And how many moles of total ions? 0.6 moles. Okay. See how that works? All right, next. How many grams of hydrogen chloride are found in 100 milliliters of a 2 molar solution? But Mr. Byers, there's no grams in your formula. Yeah. What do you got to do once you have your moles? Each other. finding the moles to begin with. Okay, so let's find the moles first. Using our formula, molarity equals moles over liters. Our molarity is 2.0 moles, and we're looking for X, or 2.4 molar, looking for X moles, and our volume is 0.1 liters. So how many moles do we need to begin with? Those of you who are done. 2? 0.2. Okay. So 0.2 moles of HCl. Then we're going to take that number and we're going to use our T-chart to go from grams to 1 mole HCl. HCl is how much?
36.
36? Okay, sounds good. Grams of HCl.
7.2.
And your answer is 7.2? If you say so.
Grams.
Yep, 7.2 grams HCl. I use 7.3 because I use 3 significant digits, but whatever. So, yeah, about 7.2. Give me a thumbs up if you got this, if you're comfortable where we are right now. Okay, any questions? Nine? Kind of approval? 9? No questions? Okay, let's do it again. Hey, this is what you're going to be doing when you do the penny lab. This is a super fun lab we'll be doing soon. Probably next week. Maybe after spring break, we'll see. What mass of NaOH is required to be dissolved in 250 milliliters to make 2.8 molar solution? And just FYI, you're going to have to do this very calculation before the penny lab. I don't know if it's going to be, the numbers are going to be the same, but the process will be exactly the same. And it's going to be NaOH. Might be exactly the same. Penny lab is fun. You're going to make gold-plated pennies. It'll be worth a cent. But you might, depending on what kind of marketing you can do, you might be able to sell it to a freshman for $1. One more? I can sell them.
This is a 1985 gold-plated penny. You don't find these every day.
Exactly. They only made them for one day, where they realized there was a huge mistake.
Don't scratch it. It's really soft. Put it in.
The strangest thing is, much as people get really, really excited about stuff, you don't hear about labs from year to year. Like, I know some of you have siblings that did the lab, but you're like, oh yeah, my brother did that. You don't hear that anymore. He traded it for like $10. I thought it was real gold, so I traded it.
I heard you guys made cookies last year. Why didn't you make cookies?
I gave you a cookie recipe. You can make cookies. You can bring them in.
Oh, did you guys make cookies for reactive?
I gave you a cookie recipe when we did Molarity. I don't remember exactly. Maybe I didn't give it to you. I thought it was. Okay, so get your moles, convert your moles into grams, and then we'll all be happy. Some of you are still banging on your calculator, so I'll give you some more time.
Calculator has feelings.
Give me a thumbs up if you have a final answer in grams. Okay, looks like almost all of you. Take another 10 seconds. If your final answer is larger than 5, raise your hand. Looks good. Larger than 10? Larger than 20? Larger than 25? Larger than 30? Oh, good. You get 28?
Yeah.
Good. So what this means is, if you want to make 250 milliliters of a 2.8 molar solution, you will need to dissolve 28 grams of sodium hydroxide into your 250 milliliters of water. That's what real life means. You just dissolve it, then you get that solution. Okay, next. This is the part where you're going to need to use your exponent key. Now again, if you use your exponent key, putting in the moles is very easy. It's 6.02 times 10 to the 23rd. If you're using your exponent key, it's 6.02 exponent 23, and you're done. If you don't like using the exponent key because your math teacher hasn't figured out how to use it, you have to go 6.02 times 10x 23, but most importantly, you have to put the whole thing in parentheses. So if you're using your exponent key, you don't have to do that. If you're not using your exponent key, you need to put the whole thing in parentheses because you will be dividing, and your calculator will give you an order of operations problem if you don't put that in parentheses. I say just use the exponential key. Impress your friends, gain fame, use your exponential key. Okay, what is the concentration when 3.0 times 10 to the 23rd ions are dissolved in 1.1 liters of water? Do you see ions present in this exercise?
Yes.
Do you see moles present in this exercise? No. How do I turn my ions into moles? Divide. So I'm going to take my 3.0 times 10 to the 23rd ions, and I'm going to divide by 6.0 times 10 to the 23rd things per mole, and that's going to give me my number of moles. Yep, Avogadro's number.
Thanks, Avogadro. You got the best number.
I love avocado.
If you got a number smaller than 1, raise your hand. Good. About 0.45 molar? So the 3.0 times 10 to the 23rd divided by 6 times 10 to the 23rd gives you about a half a mole. So 0.5 over 1.1 liters of water gives you 0.45 molar. What is the concentration of 87 ions in 2.4 times 10 to the 23rd liters of water? This is a calculation you're going to do in a simulation in a little bit. I don't think it's the next simulation. I think it's sometime next week. But again, you're going to get a really tiny number of moles, and you're going to divide that by a really tiny number of liters. By the way, if you're using the graphing, if you're using the inspires, and you just want to get an actual number, there's a couple different ways to do it. One way is to use second enter, which is approximate second enter. There's another one, but that's the way I do it. I just go second enter, second enter. So if I go 5 divided by 8, enter, it says 5/8. Great. So if I say 5 divided by 8, 5 divided by 8, second enter, it says 0.625. I find that kind of handy on these guys. Okay. With a show of fingers, what number did you get? I got a 6. 6. 6? Yeah, 6. 6 molar. 6 molar. So, again, take the ions, divide by Avogadro's number. That will give you the number of moles. Divide that by the liters, and you should get 6. Again, the reason you have to do this in parentheses, if you're not using your exponential key, is because when you divide numbers that have exponents, it tries to do the exponents, tries to divide the exponents first. That's not always a good idea. Okay, here's a question. How many ions dissociate for every mercury 2 bromide molecule? How many ions, total ions, dissociate for every mercury 2 bromide molecule? Good? Okay, so if you had mercury 2 bromide and you put a single molecule in water, it's going to dissociate into its ions. How many ions will it make? Just like if you had your skateboard, you're cruising along your skateboard falls apart, how many total parts will you have? Wheels and board. Is that what you got? 3. 1 mercury and 2 bromines. 1 mercury and 2 bromines. So if this is the case, and it is, we end with this. What are the 2 concentrations of a solution of 14 ions of mercury and 28 ions of bromine in 1 times 10 to the negative 16 liters? And yes, it is as easy as you think if you have the other one. Don't hate me, but this is homework. This is practice homework. It's really only 5 exercises, so you can polish it off for homework, bring it in tomorrow, we'll all be friends.